All right, now this is weird that we're doing chapter 5 right in the middle of chapter 4, but it's because it's about triangles and that's what we're talking about. So this is all that we're going to cover on chapter 5, what we're going to talk about today. All right, so here's the thing. If you take a ray from the largest angle, it will point to the longest side. Same if I go from the longest side, it will point to the largest angle. That is true for the largest and the smallest. Okay, so if I take a ray from the shortest side, it will point to the smallest angle. If I take a ray from the smallest angle, it will point to the shortest side. So this theorem here says a bunch of stuff about long sides and angles and whatnot, okay? So what we're first going to do is we're going to list the angles from smallest to largest here using this figure, okay? And we're going to use the length of the sides to determine who is the smallest and who is the largest and who's going to be in the middle, okay? So 8 is the smallest side here. The ray from 8 is pointing to C, so angle C is the smallest. The next number in line, right, bigger than 8 but less than 15 is 12. The ray points to A, so that's angle A. That would make the largest angle, angle B. All right, if we use this little figure here, right, 8 is pointing to C, 12 is pointing to A, 12 is bigger than 8, so A is bigger than C. It's greater than. All right, the next theorem just states the opposite, right? If I have one angle bigger than the other, that means the side opposite of the angle that's the largest is larger than the other, right? So 60 degrees is larger than 40, so EF is larger than DF. Now we're going to use those angles to tell us what is the sides shortest to longest. First off, I have to figure out what the measure of F is. It's still a triangle. It still equals 180 inside, right? So that means 60 and 40 is 100, so F is 80 degrees. Oh, not 8 degrees, you goober. Sorry. Jeez. It's really hard to... Spongy pen. Like, I just complain all the time. I'm so sorry. Okay, so we're looking for the shortest. So 60, 80, 40, 40 is the smallest angle. It's pointing to DF. Remember to write the side notation. It's a segment, okay? So the next largest side would be opposite of angle D, which is FE. Or EF, you could say either one would be fine. And then the largest side would be opposite of the largest angle. That makes that DE. Easy peasy lemon squeezy. Okay, so triangle inequality theorem. So first what we're going to do is we're going to plug in the numbers that we hear and see what we have going on. So AB is 8. So 8 plus BC is 10. That must be bigger than 15, right? Two sides of a triangle must be bigger when they're added together than the third side. That is true. Okay, so now we're going to do AC, which is 15, plus BC, which is 10. And that is bigger than the third side, right? Because 25 is obviously bigger than 8, so that's cool. Because if it's not, if two sides of a triangle added together are not bigger than the third side, then it's not even a triangle, okay? So keep that in the back of your mind. All right, now AB is 8, and AC is 15. 8 plus 15, is that bigger than 10? Well, it sure is. Okay, cool. Then this is a triangle. All right, so now that we know that's all fine and good, this is a real triangle, we're ready to move on, all right? So here we go. In triangle ABC, if AB is 19 and BC is 7, what are the possible lengths of AC? What I want to do is first, let's let AC equal x. And what I'm going to do is I'm going to set up an inequality. X is between these two values, okay? So first I'm going to take the two sides that I already have, and I'm going to add them together on the larger side. This is the largest. Here on the left side, this is going to be the smallest. And I'm sorry it's not writing correctly, but it's smallest, okay? I'm going to subtract. Always put the bigger number first because we don't want to have a negative. We're not going to have a negative length for a triangle side. That makes no sense whatsoever. All right, so for the smallest side, 19 minus 7 is 12. All right, and 19 plus 7 is 26. So if we were to talk about this, really what I'm saying here, x must be bigger than 12 and x must be smaller than 26. So if we were to say what are the possible sides, I could list them all out for you. I'm totally fine with this inequality here, but if I list them all out, if x must be bigger than 12, so 13 is a possible third side, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, whew, and 25. I thought I was going to run out of room. Gosh, oh my goodness, why did I do that? Okay, so there we are. We have them all listed out. These are the possible sides. Notice my inequality does not have equal sign, like the little equal to underneath. So it is, AC is between 12 and 26. That's how we get that done, all right? All right. All right, this next figure is probably going to blow your mind because you'll be like, no, I don't like it. But you know what? Sometimes you just can't trust the pictures that are given to you. What we do know, we know that the interior sum of all triangles is 180. So 180 minus 70 minus 55 makes this 55 degrees down here. Right? We just subtracted from 180. And we found that the missing angle was 55. Now, if we need to list the smallest and the largest side, we're going to use those angles to guide us. So the largest side, and don't freak out, okay? Because we're going to use the largest angle. It's going to point to the largest side, is AC. And you're like, no way, I'm getting my ruler out. No, put your rulers away, guys, okay? That's just how it is. All right, since this is an isosceles triangle, we have 55 and 55. So both AB and BC are the smallest sides. Sorry, I got my window open. Somebody's hot rodding out there. Jeez. Smallest sides, since they're equal, are AB and BC. All right, so don't let your eyes play tricks on you. These are the facts, kids. Trust that, okay? That's all it is for 5.5. Now we're going to talk about 5.6. We only have a couple examples to do, but you guys are so smart, you're going to get through this like nothing. All right, so 5.6, the Hinge Theorem. If two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is larger than the third side of the second. That sounded crazy. All I'm saying is 100 is bigger than 80. So if I take a ray from 100 and it points to RT, and I take a ray from 80 and it points to VX, RT is clearly larger than VX. Clearly. I mean, it's obvious. Okay, and conversely, we're going to do it with the angles. Okay, it's the same gobbledygook up here. If you want to read it, you're into that. Cool. That's why I have it there for those of you that love that stuff. But we know that if we have two congruent sides, right, and then we have a third side that is larger and is pointing to an angle for one triangle, and then we have another third side that isn't as large as the other one, pointing to an angle, we ask ourselves, who's bigger, 8 or 7? Well, 8's bigger, so that means A is bigger than D. Wowza, that was crazy. Oh my goodness gracious. One more example to go and we're ready to be on to our homework. Hey, what's happening here? All right, so we have two sides that are congruent to two sides of another triangle, and then we have some angles, and 50 degrees is pointing to BA or AB. 50 degrees is pointing to ZY or YZ. Well, 50 is the same as 50, so these bad boys are equal to each other in length. So I'm going to go ahead and give it 3 hash marks, because what the heck? I know these are congruent triangles. They're so cute. All right, guys, here's your homework for tonight. Assignment number 19, page 333, 6 through 13, 16 through 19, and 21 through 23. If you have any questions, hit me up on Schoology. All right, peace.